Hi, my name is Brandon Yee, and if you've had plants die, then you've come to the right video. I myself have had several plants down to me, and that's why I decided to create an embedded system. So I actually had the plan to actually account for three factors to monitor and regulate the light, the temperature, as well as the moisture of a plant. And accordingly, I was going to have motors regulate those three factors. I was going to have two servo motors and one stepper, and one of these motors would actually control this cardboard piece, which would allow varying amounts of light to shine into the pot if the plant wasn't receiving enough light. And I would also have a motor connected to a stopgap, which would move the stopgap when the plant wasn't receiving enough water, and the stopgap would be connected to a little plastic wire, and water would actually flow through that wire directly into the pot when the plant wasn't receiving enough water. And I would also have a fan piece connected to another motor, which would rotate and blow air onto the plant if it was too hot. And originally I was going to try to import Arduino libraries to actually control these motors, but then what ended up happening was I couldn't figure that out. So instead, I opted to try to get an H bridge, but the H bridge was going to come in a few weeks to a month. So rather than trying to get the motor to rotate in two directions, I wanted to actually focus on trying to get uh, one direction working. So originally, I was going to try and connect this to an actual to my microcontroller, but I realized my microcontroller had an output of 40 milliamps when the starting current of this was 300 milliamps. So to account for that, I had this circuit which would allow the motor to get the current which it needed. So I had a GPIO pin here, and I chose this 1 kilo ohm resistor so that I would have a 2.6 volt drop here and a 0.7 voltage drop across base and emitter. And I chose this transistor knowing the current requirements of the servo. And I also have this flyback diode here, which I actually placed so that when I would disconnect this from the rest of the circuit, I would actually protect the MCU from back EMF because the current would just flow through this area without actually going to the rest of the circuit. And I have this voltage divider circuit here because I actually don't have a 5-volt supply for the motor. So I just created this circuit based off of a few resistors to get that output. And what ended up happening was I may have blown my GPIO pin because upon creating this circuit, I stopped getting current flowing through this. So rather than actually trying to fix this circuit and possibly destroy other GPIO pins, I decided it was safer to actually opt with what I had over here. So you can see right now I have a piezo buzzer and two LEDs, as well as a moisture sensor and a temperature sensor. So right now, uh, this green LED indicates that both the temperature and the moisture levels are okay. But in this situation where the temperature is actually above a certain degrees, you'll see that this LED will actually flash. This red LED will flash to indicate, and when it returns like to normal levels, then the green LED will be on. And also with this uh, moisture sensor here, when the moisture is too high or when the plant pot has too much water, this piezo buzzer will actually go off. So you can see here when I place this inside, this speaker will go off. And the moment that this actually goes back to not flashing, meaning that the red LED, meaning that the temperature is okay, and that is okay, then the green LED will actually go back to the normal state. And one interesting thing about this project is I actually used two different timers. So rather than actually calling the wake up timer for every single temperature, while actually like implementing this, I decided to actually call the wake up timer and reload the value only when the temperature went above a certain value. That way, I would only have this LED flashing for a certain temperature rather than having it flash for every single temperature. And while working on this, I actually learned a few things. I learned about circuit design. I learned how to read data sheets, and I also learned the importance of actually doing research. As you can see over here, if I had properly done research or on the actual Arduino libraries or ordered the H-bridge a lot faster, then I possibly could have gotten these motors to work. But overall, I feel like I've learned a lot and become a better engineering student because of it, and I'll be sure to take these lessons into Eng 4000. Thank you for watching.